Question 3. Use mathematical induction to prove that n cubed plus 2n is divisible by 3 for n is an element of natural numbers. Now, natural numbers starts from 1, 2, 3, and it continues right up to infinity. Right. So the main thing that you need to remember is that natural number starts from 1. So let us prove this mathematical induction. So we start with the base case. So for the base case, what we have is for n is equal to 1. If n is equal to 1, we have n cubed plus 2n, which is equal to 1 cubed plus 2 into 1 is equal to 3. And clearly we can see that 3 is divisible by 3. So if 3 is divisible by 3, remember the quotient is equal to 1, right? If you substitute 2, you will get 2 cubed plus 2 times 2 cubed is 9, 2 times 2 is 4. Sorry, you will get 2 cubed, then 2 times 2, which is 4. So 8. 8 plus 4, which is 12. 12 is divisible by 3 by 12 is divisible by 3 because we are getting a quotient of 4. But remember, we're not going to prove for every single case. Base case is always the starting value. Base case is always the starting value. Now, for the hypothesis, we call it the inductive hypothesis. Inductive hypothesis. So what are you claiming? So what we're going to say is that assume that n cubed, k cubed plus, for the inductive hypothesis, we always have like n is equal to k. K cubed plus 2k is divisible by 3 for, not for n, for k, an element of natural numbers. This implies what we're saying is k cubed plus 2k can be written as, in other words, divided by 3, we are going to get some quotient. In other words, what we can say, let q, since k cubed plus 2k divided by 3, since k is a natural number, q is also a natural number, q is an element of natural numbers. For every new variable that you introduce, you need to define them. So what we can say is this implies k cubed plus 2k is equal to 3q, just taking it across. Now, the next part comes, which is called the step, the most important step, which is the inductive step. So the inductive step basically says for n is equal to, prove for the next natural number, k plus 1. Because if you can prove it for n is equal to k, where k is an element of natural numbers, let's try to prove it for the next natural number after k. So what we can say here is k plus 1 all cubed. Remember the formula was n cubed plus 2n. So k plus 1 all cubed plus 2 into k plus 1. Now the goal is to show that this expression here that I have written is divisible by 3. How? If we expand k plus 1 all cubed, we can get k cubed plus 3k squared plus 3k plus 1. If you do not know how to expand k plus 1 all cubed, I used binomial expansion here. If you do not understand binomial expansion, please watch my video on binomial expansion. Subscribe to my channel, it will be there. Plus 2k plus 2. Now, we know that from the hypothesis, above hypothesis, we know that k cubed plus 2k is divisible by 3, which is equal to 3q. Now what we are left with here is 3k squared plus 3k plus 3, the balance of the terms, right? So just highlight the balance of the terms. The balance of the terms are these. If we add them all up, we get this. Now we can take out 3 as a common factor. Q plus 3k squared plus 3k plus 3. We can clearly see that this expression is divisible by 3. Hence, hence, by mathematical induction, by mathematical induction, n cubed plus 2n is divisible by 3 for all. The symbol means for all n is an element of natural numbers. Question 4. Determine f prime x by first principles if f of x is equal to 1 minus x. Now, we know the formula for first principles. F prime x is equal to limit as h approaches 0 of, I like to write it like this, f of x plus h minus f of x all over h. All over h is the same thing as saying times 1 over h. Now, we can write as limit h approaches 0 of 1 over h into. Now, look at this. F of x plus h, substitute f of x plus h in here. So remember, we are finding f prime x. So f of x plus h will give us square root of 1 minus x plus h. Subtract the square root of 1 minus x. Now, we have a problem over here because if we substitute 0 directly, we will get division by 0. So what we can do here is multiply by the conjugate to get something in the denominator. So if I multiply this by the conjugate, I can say square root of 1 minus x plus h plus the square root of 1 minus x over the same thing, square root of 1 minus x plus h plus the square root of 1 minus x. Now, this here is equal to limit as h approaches 0 of 1 over h into. Now, for the top, what we have is difference of two squares. So we have 1 minus x. Can you see? 1 plus 1 negative sign and 1 positive sign. We are multiplying these two out. So 1 minus x minus h in here, subtract 1 minus x divided by, I will leave the bottom term as it is without taking the negative inside. So 1 minus x plus h plus square root of 1 minus x. Now we can see that limit as h approaches 0 of 1 over h into, simplifying the top, should give me 1 minus x minus h minus 1 plus x all over. Okay, so for the top, what I can see is that minus x and the plus x cancel out, the plus 1 and the minus 1 cancel out, and you can see that h and that h also cancels out because all we are left with is minus 1. So remember, the h and the h cancel out, we're still left with a negative square root of 1 minus x minus h plus square root of 1 minus x. Now, we are almost close to the answer. So what we can say is limit h, we don't need to say limit h approaches 0 because we can substitute 0 in directly. So my solution is, okay, let me just write down what we have so far. H approaches 0 of minus 1 over square root of 1 minus x minus h plus square root of 1 minus x. Now substituting 0, the only thing that's 0 is that h. So we have minus 1 over, see, this is a 0. So square root of 1 minus x plus square root of 1 minus x is minus 1 over 2, 1 minus x. And that is the solution for this. If you want to check your answer, just to check your answer, what's the method for checking the answer? We know that f of x is equal to 1 minus x to the power half. So f prime x is equal to half into 1 minus x to the power negative half times negative 1 by the chain rule. So what we left with is minus 1 on the numerator and 2. Remember, all of this goes down, it becomes square root 1 minus x. So indeed, my answer is correct. Make sure you always check your answer, guys.